Hello everyone, welcome to my channel Accelerate AI Careers. Today I'm releasing my new series, Popular LLM series, wherein I will be talking about one LLM model each video, wherein we'll be delving deeper into how the model is trained, what kind of parameters does it have, what was the training process it went through, what was the testing process it went through, what were the metrics on which it was evaluated, how does it perform when compared to other models available in the market, what are its advantages and disadvantages, how you can use it in your projects, what kind of projects it is suitable for. So if there is anything which you would like to know more about the model, please mention them in the comments. Also, if you have not subscribed yet, subscribe to my channel for similar videos in the future. And let's delve deeper into Llama 2, which is the topic of the discussion today. Now, what is Llama 2? Llama 2 is a collection of pre-trained and fine-tuned LLMs from Meta AI. It has totally been open sourced, so anyone can use it. You don't need any sign-ups or any fees payment to use Llama 2. The parameter range for Llama 2 is 7 billion to 70 billion parameters, so it can be used on any kind of PC or laptop because it has smaller versions also available. Now, Llama2 Chat is another version of LLM which is fine-tuned and optimized for dialogue use cases, primarily to make conversational bots. We will delve deeper into what a conversational bot is, what kind of dialogue use cases we can work upon. In fact, we will make a project for using Llama2 for one of the chatbots in another video. Now, why learning about Llama2 is really important. This model outperforms open source chat models on most benchmarks tested, and it is based on their human evaluations for helpfulness and safety. And it might be a suitable substitute for closed source models such as ChatGPT and might bring down your cost of project a lot. And it democratizes AI use since everyone and anyone can use it. Hence, learning more about Llama 2 makes sense. If you have any questions, mention them in the comments. Let's see how this model has been trained and what are the distinguishing features for Llama 2. So now I'll first walk you through the research paper which I'm referring to for Llama 2, and I'll walk you through each and every details for the research paper, and then we'll look at important aspects out of it. So this is Meta's research website where it shows that Llama 13 billion parameters outperforms GPT-3 175 billion parameters. Similarly, they have talked about Llama 65 billion parameters when compared to Chinchilla 70 billion and Palm 540 billion parameter model. So we will look into each of these details, but I'm just going to show you their website. And then here you can download the research paper to go through it. I myself went through it 3-4 times to understand it in a better way. So you should spend your time on it. I copied the URL and I've opened the research paper here. The research paper is this. So I will be touching each important aspect of this research paper. I'll be referring to certain sections, certain segments here. And if you want to look more into the details, feel free to go through the research paper. I will add the link of the research paper with the video. So if you see here, it talks about what data has been used for pre-training. And then it talks about the architecture of the model, what are the different kind of embeddings used, and then how, if the implementation has been done, it's been compared with GPT-3, Chinchilla, Palm, and Gopher model, and you can see what kind of metrics they have used to do the comparison. And this is all zero-shot performance. Zero-shot performance means when you do not give the model any set of examples of your data set, and you just test its performance without giving it some sample data set. This is the results section where they talk about zero-shot prompts results and few-shot prompt results. And you can see they have compared 0 shots, then 1 shot, 5 shot, and 64 shot performance. And then there is closed book question and answering, which has been tested for 3 models, Llama, Palm, and GPT-3. So you can go through the performance comparison for these 3 here. There are several links attached for the data set, the natural questions that have been used. So if you are really interested, go through each of these segments. I went through it. So I would say that it is useful, and I will touch details for each. Then they talk about each use case. So like they talk about question and answering first, how does it perform there? Then reading comprehension, and they have used race reading comprehension benchmark. And for the details about the benchmark, you can go through this research paper. Then mathematical reasoning, how this model compares with Palm and other models. As you know, Palm is really good performer on mathematical reasoning because it has largely been trained on mathematical data sets. So how Llama 2's performance compared to Palm would be a good thing to see. Then how does Llama perform on code generation? I myself have used Llama 2 so many times for generating SQL or code. I also used it to do a code translation project. So let me know when you have used Llama 2, how did you see its performance? And when we delve deeper into massive multitask language understanding here, it talks about the model's comparison on MMLU metrics. Then it also checks for the toxicity level of the model, what kind of performance it has on toxicity parameters. And for each data set, its performance has been traced here on question and answering and common sense reasoning. So some toxicity prompts and its performance has been mentioned here. Then they have segregated the toxicity performance on gender, religion, race, color, sexual orientation, age, nationality, disability, physical appearance, or socioeconomic status. This is extremely important when you get into full time roles. Whenever a client thinks about adopting any kind of large language models, they are really anxious about what kind of discrimination or any kind of bias the model shows towards certain set of audiences. So you have to be mindful about the model's performance on any kind of ethical grounds. There are so many litigation cases which come around because of these. So any model needs to be negatively and positively tested on these parameters. So then truthful QA, again, it is a metrics which is aimed to measure truthfulness of the model. So you can go through the research paper in detail. Ask me your questions in the comments. If you do not understand something, I have understood this paper really well. So if there is something which bothers you and which is not addressed in my video today, do not worry. Share it in the comments and I'll be able to address it. So after this, they have made conclusions on the particular performance of Llama A 13 billion as well as Llama A 65 billion with respect to the other models. And then they have included all of their references. So take your time just going through this research paper and my video, of course, and let me know if you have any questions. I'll be happy to address it. How is Llama 2 different from other LLMs in terms of training process? So we will be discussing that and I will be using Meta's technical report for reference, which I will use to explain how the training process for it is different from other LLMs available in the market and what kind of improvements does it have. I will be attaching the link of technical report also with the video. You can refer to it yourself as well. Llama 2 is powered by Ghost Attention, that is GAT, introduced in this technical report paper, which improves multi-turn memory. Now, what is GAT and what is multi-turn memory? How does GAT improve multi-turn memory? I will explain it by an example. In this below image, on the left side, you can see a conversation between a chatbot or an assistant, conversational assistant with the user. And on the right side, you can see the same conversation with an assistant and a user. But the left side is using multi-turn memory and the right side is using GAT, which is ghost attention, which Llama 2 uses. Both the chatbots have been given instruction in the beginning of the conversation that always answer just using emojis. So basically, the chatbot or the conversational assistant needs to respond just by emojis. If you see on the left panel, when it is using multi-turn memory, it is initially responding using emojis. When it says, "Who are you?" it responds by a chatbot emoji there. Then it asks how to go from Paris to New York. And then it responds by text. So basically, what happened? It forgot the initial instruction given to you to always answer with emoji. While on the right side, which uses GAT, you can see when it is asked, "Who are you?" it responds by an emoji. Then, how to go from Paris to New York, it again responds by emojis. What causes the extinction of dinosaur, again by some emojis. And then Italy, it tells you everything about Italy again by emojis. So it doesn't forget what were the initial instructions given to it. So you can deduce that when you tell your chatbot that act as some public figure or respond succinctly or only give logical answers, semantically correct answers, all those instructions which you give to your model initially, if you have GAT implemented within the model when it is fine tuned, then it remembers those instructions till the very end. Whereas if it is just using multi-turn memory, there is a tendency that it will remember the instructions given to it for the initial time being, but it will slowly start on losing that information. You must be wondering, how does GAT work? So let me explain it to you in simple terms. Assume we have access to a multi-turn dialogue dataset happening between two persons. For example, one would be a user, other is an assistant. With a list of messages to and fro, U1, A1, U2, A2, UN, AN, where UN and AN correspond to the user and assistant messages for turn N respectively. Then we define an instruction, say I, that should be respected throughout the dialogue of conversation between the user and assistant. For example, instruction could be act as so and so person. We can then synthetically concatenate this instruction to all the user messages of the conversation. Next, we can sample from this synthetic data using the latest RLHF model. RLHF stands for Reinforcement Learning from Human Feedback. We now have a context dialogue and the sample with which to fine tune a model, in a process analogous to rejection sampling. Instead of augmenting all context dialogue turns with this particular instruction, we can drop it in all but the first turn. But this would lead to some mismatch at training time between the system message, that is, all the intermediate assistant messages that come before the last turn, and our sample. To fix this issue, which could hurt the training, we simply set the loss to 0 for all the tokens from the previous turn, including the assistant messages. For the training instructions, we created a few synthetic constraints to sample from. For example, hobbies, you enjoy tennis, soccer. Languages, speak in, for example, French, or public figure, act as, for example, Narendra Modi. To obtain the list of hobbies and public figures, we asked Llama2 Chat to generate it, avoiding a mismatch between instruction and model knowledge. For example, the model to act as someone it had not encountered during the training. To make the instructions more complex and diverse, we construct the final instruction by randomly combining the above provided constraints to the model. When constructing the final system message for the training data, we also modify the original instruction half of the time to be less verbose. For example, always act as Narendra Modi from now. Figure Narendra Modi. These steps produce an SFT dataset on which you can fine tune Llama2 Chat. Now, how do we evaluate GAT? So, basically, the meta researchers applied GAT after RLHF version 3. They reported a quantitative analysis indicating that GAT is consistent up to 20 plus turns until the maximum context length is reached. If you refer to the research paper, you can refer to Appendix 3.5 where they mention about it. They tried to set constraints not present in the training of GAT at inference time, for instance, always answer with haiku, for which the model was found to remain consistent. Despite its utility, meta researchers have mentioned that the current implementation of GAT is vanilla, and more development and iteration on this technique would likely further benefit the model. For instance, they could teach the model to change the system message during the conversation by integrating such data during fine tuning. Another important aspect that is highlighted in the report is the effect of RLHF on Llama 2. And the below graph from Meta's paper shows how high quality human preference data, which is obtained from Surge AI, keeps on improving Llama 2 without saturation. So you can see the scaling trends for the reward model and how helpful it is. They also call out the importance of supervised fine tuning data quality. In the quality is all you need section of the research paper, it's not about volume but diversity and quality of the fine tuned data. Let us look at some of good to know facts about Llama 2, which I have deduced from this research paper. First, Llama 2 likely costed around $20 million plus dollars to train. Second, it is commercially friendly license now, which can be easily used by companies, which was an issue with Llama 1 earlier. Llama 2 can be accessed via managed services in IBM, Watson X, Azure, and AWS. Fourth, Llama is trained on 2 billion tokens with 4 variants ranging from 7 billion to 70 billion parameters. Fifth, a human study conducted by meta researchers on almost 4K prompts to evaluate Llama 2's helpfulness. So it is largely tested on human feedback as well. They used win rate as a metrics to compare models in similar spirit at the Vicuna benchmark. 70 billion models roughly tie with GPT 3.5 and performs noticeably stronger than Falcon, MPT, and Vicuna. These real human ratings should be trusted more than academic benchmarks because they typically capture the in the wild vibe better. Llama 2 is not yet at GPT 3.5 level mainly because of its weak coding abilities. On human eval score, standard coding benchmark used, it isn't nearly as good as Star Coder or many other models specifically designed for coding. That being said, I have little doubt that Llama 2 will improve significantly thanks to its open weights. And now Llama 3 has been released today, so I'm looking forward to using it for coding purposes as well. Number 9, Llama 2 is intended to be used in English with all 90% of the training data being in English. Number 10, almost half of the paper is talking about safety guardrails, red teaming, and evaluation. Thus, this model has been designed taking safety as the primary focus. The commercial license specifies a number of harmful use cases that violate the license, including spam. It has been documented to such great lengths when compared to ChatGPT's or OpenAI's documentation, and it is really helpful for any user who adopts it. In prior works, there's always been a trade off between helpfulness and safety. Meta has mitigated that by training two separate reward models. Those reward models are not open source yet, but it would be really beneficial if they are made open source. Number 13, no need to convert sensory input signals such as video, audio, images, 3D perception to text descriptions and then feed to an LLM. It is a bit awkward to do that. In Llama 2, it can be done directly. The direct feed for sensory inputs to LLM can be done. I'm going to summarize the training process for Llama 2 Chat for you. Even though I explained it in steps earlier, I'll just summarize it using this below figure from Llama 2 Chat's research paper. The entire training process begins with the pre-training of Llama 2 using publicly available online sources. Following this, they create an initial version of Llama 2 Chat through the application of supervised fine-tuning. Subsequently, the model is iteratively refined using reinforcement learning with human feedback (RLHF) methodologies, specifically through rejection sampling and proximal policy optimization (PPO). Throughout the RLHF stage, the accumulation of iterative reward modeling data in parallel with model enhancements is crucial to ensure the reward model remains within the distribution. You can see the diagram here, different components. If there is something which is a doubt for you and it is not clear, message in the comments. I will address it. Llama 2 is very comparable to ChatGPT 3.5 in most of the benchmarks. Particularly, it beats ChatGPT in human evaluation on helpfulness, win 36%, tie 32%, loss 32%, other than coding. Looking at the data mix, coding data is still quite small, classified under the unknown language category. Llama 2 outperforms all other open source models including Falcon and MPT and has 3 variants including 7 billion, 13 billion, and 70 billion. The 70 billion variant achieves the top performance across the board. Benchmarks were done based on standardized ones like MMLU and head-to-head competition against other models including Palm 2 Bison and ChatGPT 3.5. Model toxicity and evaluation is another large focus, including evaluations like red teaming, which were found in the Claude 2 model card. Generally, Llama 2 performed very well with fewer safety violations than ChatGPT in human evaluations. Now, interesting two other facts are the tokenizer is the same as Llama 1, which is quite interesting, but the context length is now 4K. Double the original. Llama 2 is trained on 40% more data than Llama 1 and performs well against benchmarks. I will release a similar video which will encompass the details about Llama 3. So please subscribe to my channel and post your comments to help me make the next video better. Thank you.